Welcome to Assembly 2009 Summer Seminars. And next we have here Eskil, who is going to tell you about the game he have developed and especially the technology behind it. And the game is called Love.
So I'm going to start off by asking how many people know about Love, have seen screenshots or videos or whatever? Okay, that's pretty good. How many people here are technically proficient or programmers? Oh, awesome. That means I can talk about the fun stuff. I'm going to start by just going through all the tech that went through this game. And actually, normally I spend a lot of time talking about the game, and I'm not actually going to do that. I'm going to be available here, so if you want to come talk to me later, we can do that, and you can ask whatever you want. But I really wanted to give a talk about some of the tech and some of the thoughts behind the tech. And especially fun to give a talk like that here, because I think that the sort of approach I use is somewhat similar to the demo scene. So the game has been in development for a little over 2.5 years. It's an insane project for one person to do, since it's basically a first-person, not so massively multiplayer, online, persistent world game. It's very, very near completion, and I'm really excited about where I am right now. So just starting the engine, going to have a look around. This is sort of the environment. And the environment is, the rendering engine is a completely custom-built, from the ground up, OpenGL engine. And as you can see, it doesn't really look like other games. It has a very sort of different painterly look. And one of the base things is, if you're going to do a game like this, which is this massive world that is dynamic and really cool and, you know, really, really a lot of work, actually, you need to be really economical. And my point in making this game was sort of to show that if you're a single person, you can make a really awesome game if you're just a lot smarter than everybody else. And if you just think of smarter ways of doing things. Because the game industry, people do things in a really stupid way, and that means that it's really expensive. And if you're just a little bit smarter about it and do things in a different way, you can really get away with a lot of things. And this was kind of the proof of concept. So obviously, there is a lot of limitations when you sit down and say, OK, I'm going to make a huge game by myself. And graphics was one of those. I'm a graphics programmer by heart. I used to be in the OpenGL Architectural Review Board to actually help develop OpenGL for 5 years. So OpenGL is my home, and I love graphics programming. So the idea of not making a graphically intense game was kind of not really interesting to me. I didn't want to make it like an iPhone game or something simple, something 2D, because the thing I enjoy the most is actually doing the 3D programming. So the idea here was to make a game that has a sort of a painterly look with not too much detail, but sort of a lot of atmosphere. And a lot of games these days go on to this idea that if you have a lot of tech, it looks good. One of the examples of that I think is a pretty bad-looking game is Halo 3. Halo 3 has an amazing engine from a technical point of view. It does all these really, really amazing stuff, except it doesn't look good because they have too low poly. They have so much of their force going down to doing these complicated lighting and post effects and all that stuff that they don't actually have any polygons to draw the characters with anymore. And there's too few textures. They can't draw the full screen, so they have to scale it up so it's not full HD, and everything looks really crappy. And I kind of wanted to do the opposite way of say, OK, let's do something extremely simple, but let's make it really, really good looking. Let's make, the little things we try to do, that's perfect. And let's not try to do something that doesn't look good. So I'm going to just start a city here. There we go. So this is an object. And now the environment around this is editable. This menu you can see here is a cheat menu, so I can bring up all the stuff in the game. This means I can just grab the ground and pull it up. Whoops, I pulled it down. Here we go. So you can just pull up you can start building. So the entire thing is dynamic. You can play with it. So you can also build caves. So you can see here. So now we can build something. I don't know what we're going to build here. We're just going to build some sort of trench. And here we go. Jump down. And then we push in, and now we're underground. So here we have a little underground lair. So you can see it's really easy to sort of build stuff. And to explain how this engine works, it's actually, if you think about it, if you think of a normal height field, it's a grid, right? And each vertex is shared by 4 other quads, right? And you can pull it up and down. And then you can do, effects like you can throw a grenade, and then you can just paint in the height map, right, to make a hole, right? So the entire world is extremely dynamic and fun. The thing about height map is you can't really do very much with it. You can't do a wall, for instance. You can only do slopes, right? It works really well for sort of a landscape, but then you have to have, buildings and things on top of it. Oh, the sun is going down, sorry. So that's kind of boring. So then we need to actually do something more advanced than that. So what I do is I have a grid, and for each of these corners on a quad, I actually have their own value. That means that you can have one quad like this and then push another block up, right? So you can get a sort of a real ledge, right? And that's sort of the base system. But then, in order to make caves, I have a Boolean for each one of those that says, is this a cave? And if it's a cave, I don't just have these 4 values. I have 8 more values, which is a floor, which is 4 values, and a ceiling, which is 4 values, right? And when I have this really simple data structure, I can take that data structure and then put it through an algorithm that spits out polygons. And since this data structure is really simple, I can really easily generate content. So that's what I do. The entire levels, everything you see is generated by algorithms. And it also means that I don't just generate a bunch of content and say, this is the content done. I actually can regenerate the content, right? I can change the content. So you saw here I started building. This is just something I can do because I have this really dynamic environment. So for instance, I can take out this thing, which is a rocket. See if I can hit something. And you can see I can just destroy the environment because everything is destructible. And destructibility is obviously something that's really, really hard to do normally. But when you build your game around something really simple like that, like a height field, you can do destructibility really easily. Is this thing on? Yeah. There we go. So the idea when you build a game is to sort of think of something really simple, a basic structure that you can do a lot with. And then all of a sudden, all these things become really simple to do. I was at Game Developers Conference this year, and they talked about the game Fracture. Has anyone seen Fracture? Okay, it's a game where everything is destructible. And basically what they had to do was build all the models and then crash them, build tiny little pieces of them, and then put them back together, and then have the ability to switch everything from the destructed to the and then everything gets really complicated because of pathfinding, because you can't just assume that a character can walk this way because what if a big beam falls over and is in the way and things like that. And they talked about how complicated that was. But the end thing they said at the end of the talk was, well, what we really prove is you can make a destructible game. Finally, with the technology we have today, we can do a destructible game. And I thought, what about Super Mario Brothers? It's a completely destructible game, and it's 8-bit. We could do it in the 80s. It was easy to do in the 80s. It's really hard to do today, right? Because today we think, oh, we got to have 3D engines, we got to have really complex things, right? And we try to make it so hard for ourselves in the beginning. We set up these hard goals, so everything has to be modeled by Maya, right? And then from there, we can't sort of go back and make everything destructible. So if you build your world through some other way, build some other type of data structure that you can control better, that you can do all these things. Like, for instance, it's really easy. I have loads and loads of things like, if I'm on this block, which is the block to the west of it? And then I get an ID back, so I can find that one. Is this block taller than the blocks around it? And I can tag numbers on blocks, and I can do all these kinds of things that make it really easy to sort of process. And if you think of a grid, it's actually like a bitmap. So a lot of the effects you do are actually sort of image effects, right? So you can do smoothing, for instance, and you can do all these cool effects. The sun is coming up again. So this world is actually round, and you can see it has a slight bit of curvature. And this is actually not just one grid. It's actually 6 grids put together in a cube and then rounded. So that's how I get sort of the world. That's my basis for the drawing. So that doesn't look really good because it means it's going to be really blocky. What about this thing? There's an object here. So what I've done is actually I've modeled an object by hand, and then I made it with a square bottom. And then I can say, this surface is of this type. And that means you're not going to draw a quad there. You're going to take this object and merge it into it and sort of squish it in to fit, right? And then you can rotate it, and you can do all kinds of things. How do you squish it if it's standing on a leaning surface and things like that. So right now, here's some trees. This game has a single tree model. All these trees are exactly the same, but since they're all a little bit squished, and since they're all, a little bit different because of this fitting process, and because all the squares are not actually completely square, they're all a little bit, randomized like that. You can look at these 2 trees, and you couldn't tell that they're actually the same model. It looks like they're 2 trees from the same species, but you can't immediately say, you can see they're all sort of aligned and perfect, right? So this is really something you have to think about when you make games today, is that how do I make it very, very little content, and how do I sort of expand this content so that I get it over and over and over again, right? And when I actually designed this engine, I made it possible to have multiple different trees, and it would random it. And I made one tree, and I couldn't tell that there wasn't many trees, right? So that's when you know that, okay, this is working. So that's how I get a lot of I get the stairs here, for instance. There's just a little model with just a few polygons. You can see the little top here, also hand-modeled objects. And then you can see this area. This is sort of just a blocks. There's no special type. I'm going to fly a little bit to show you. So here you can see an edge. But you can see right there, it's sort of an edge that's been cut here, right? And you can see this one has been cut off like that. So they actually don't look like cubes. And that's because what I did was that I modeled a little object that is just a corner, right? And that's normally, 20 polygons or something. It takes me 1 minute to make this thing, right? And then I say, this is a corner, and it's of this type of mountain. And then it can just, as soon as it finds a corner, it just says, oh, this is a corner, I'm going to take this 3D model, instead of just making a block here. And that means that this entire world has, I think, 4 or 5 different corners that I made. And that's about 5 minutes of modeling. But I spread them out all over the world. They're all rotated differently. They're all squished together differently, which means that they all look differently, and you get this really organic look, even though you haven't actually spent that much time. If somebody would model this environment, I mean, this is months of work, right? And now it just happens automatically. So it's a lot about being smart like that and sort of making little pieces. And it's important when you do this that you still want to art direct it, right? You don't want to just say, do whatever, because you want to control it. But by making these little pieces, you can still say, oh, this is the geology of these mountains. This is the way they look. This is how they're chipped. This is, this is the idea of that I want to convey with this image without having to, make a model that is huge. Actually, if we just look around ourselves, the model, the geometry that fits in the memory, it actually allocates 128 megabytes just for the the geometry. And that only covers the geometry around you. So it's a massive amount of geometry. And this game is actually completely hardware-wise bound to the number of vertices. The pixel shaders are pretty light, actually. So now you can see that we have this painter effect. And I'm going to head over this direction. I hope there's sun in this direction. So in order to make it look less polygony, because that was really a goal, you can use a lot of different mapping technologies, bump mappings and relief maps and things like that. But if you think about it, pretty much all games look like that. It's like the Gears of War look has become sort of cliche. We've seen it in every damn game. Everything looks like it's what's it called? when you make like plastic and you bump it together to make cellophane, for packaging and things like that. Everything is sort of blobby and sort of glossy and looks really shiny. That's kind of how everything looks in modern games because of the filtering. So that looks really bad. So I wanted to do something different. So I have done a bunch of things, and normally I don't show this, but I'm going to give all my secrets away. So what I do is I draw a lot of particles in the world, and you can actually see the particles now, and I think I can turn them off. You can see there's a pretty big difference just how nice the world looks with and without the particles. And the particles are 4 vertices that is in the same spot. And then in the vertex shader, I expand them in 4 different directions, so you get a full sprite, right? And then I have a very, very simple simulation that I just let them flow over the landscape. But the cool thing is that if you do sprites, you always have this problem is like, if the sprites all gather in one spot, right? You have a lot of sprites in one area, and then you walk into that area. It's like, if you play Counter-Strike and you walk into the smoke, you get this really, you draw 50 layers on top of each other. So you lose all your performance, right? That's really bad. So what I do is that when you move the sprite closer to the camera, it starts fading it out. And once it comes so close that it's completely faded out, I just don't expand the vertices. So then the sprite is infinitely small. And that means it's not going to take up any pixels, right? And that means I get no overdraw. And if you're really lucky, you can actually see that every once in a while when you sort of see a smoky area. When you walk towards it, the smoke sort of disappears. So, and that also helps with problems like, for instance, if you have a lot of smoke in your face, you can see sort of the pixel coming up. The next thing I do is all the grass. And the grass is really simple. It's actually just a surface standing like this, a quad, with a clip map on it, or alpha test map, right? So that's really simple to do. But I realize I don't just do that. I do it on all edges. So if you look at this edge here, it looks really sort of rugged, right? And that's actually because what I do is that for each edge that I find, I put a polygon like this, 2 polygons, 1 for each side, quad, right? And then I texture them with some surface that is uneven, right? And then I light them, even though they're sort of in a different direction from the 2 surfaces, right? I light them as if they have the same normal as this surface. So actually, if you look carefully here, you can see here, I can see this edge here. It's a little bright, but you can see it. And then when I walk like this, now you can see it's straight because it's actually going straight towards the camera, right? And now you can see the other side. So you can see the cheat, right? And actually, I can turn it off, I think. There we go. So now you can see everything is really boring. And then I can just turn it on and off. Right? So that's a really sweet thing. I think you can see it on the trees pretty well. You can look up here in the trees. They look pretty boring. And then I just do that. And now they look like God knows what. Really fluffy, right? And that just kills the whole look of ooh, it's polygons, right? Because we're so sick and tired of seeing polygons. So you really want to sort of remove that and just look at the ground here, right? Boring, not boring, boring, not boring. So that's a really sort of easy trick to make it look a lot better. Let's see where we can go. And you can do it teeny tiny as well. You can see this edge. It's almost straight, but just gives it a little bit of definition, right? Gives it a little bit, and then you turn it off and it looks computer graphics. Not computer graphics, computer graphics. So those are pretty easy things to do. I mean, that's something you can do in like OpenGL 1.0. You don't really need any high-tech stuff to do it. It obviously means that you got a lot more geometry. So if you have a hardware-bound problem, you know. This is a pretty crappy laptop. It's cost me, about 1,000 euros or something like that. And it runs at 60 frames per second. So, I mean, this is a really, really fast game. And that's always been my idea, that you should be able to play this game on a really crappy laptop. So it's not a high-end game. So this is a boring area to show this effect, so I'm going to keep walking. So other things I do is the post effects. So the post effects are pretty important. And what I do is I have a bunch of them. Let's see if I can. There we go. So here I turn off the first post effect I have. And you see it's pretty big difference here. And what it actually does is that for each, I draw everything in an off buffer, and then when I draw it into the real buffer, I actually sample not just the pixel, but I sample a number of pixels. And then I take the darkest one of those pixels. And that means if you draw a very thin black line, it will become a thick black line, right? And that means if you look at, if I turn it on again, you can see here, everything sort of fills out, right? Everything sort of blurs together a little bit. You see there's a pretty big difference. So, oops, that was here's the difference. You can see that everything sort of, you can see the black mountains here, the rocks sort of, they expand a little bit when I turn it on, right? But they also get a little bit softer, and they get, fluffier. And that will mean that characters and objects and things like that will sort of bring themselves together. So let's turn on the grass again. There we go. So another effect I have, so this is without. And now you can see I have a noise as well, and I have some color correction. If I turn off the color correction, it looks like this. So now if I turn this all off, let's see, what was that one? Like this. This looks pretty much like a polygon model, right? It's got fog now, which makes it look okay, but especially if we walk towards the sun, you'll see these are definitely polygons, right? When you see this, there's no doubt about it that this is computer graphics. This is not a painting. So those effects are pretty easy to do, actually, but they sort of mitigate a lot of other work, right? I don't have to do textures because if I turn everything on here, I get the noise, I get the interesting details in the different distance just by these effects. So that's really what you want to do, is you want to sort of hide things, put fog on things, put particles on things, and mush everything up as much as possible, right? Because having your artists, if you have artists sitting every little pixel one by one, is really expensive. So I've always dreamed of making a game where I would have a studio of 100 programmers and one artist. Because it would mean that we would have to spend all our time building the most awesomest tools for this person, right? The engine would have to do everything. And the artist would just draw with, very rough brush strokes, like, okay, I want a city and I want a thing, and then it would just happen. So I'm going to see what we can do. Yeah, let's click here. I'm going to go back home. I'm going to get my ass handed to me right now, because I'm going to spawn in some characters. And they kick my ass, I think. No, they don't. They're friendly. So here you can see the characters. They're a little bit crazy right now. And you can see they actually have a cloth sim on them. That is a real cloth sim. And they're actually procedurally animated also. Not very well, but they're animated. I can actually shoot them. No, I'm sorry. Oh, yes, that's the problem. I spawned them into my own city, and that means we're on the same team, so they're going to be friendly. I'm working on this code right now, so that's why I can see the names of them over their heads. It's a feature of that. So let's show some weapons just before fun. See if we got some. We got rockets and things like that. So what do we have more? What's this? Oh, it's grenades. They're pretty. See if they explode. Boom. Yeah, so you can play around. It's a game. It's supposed to be able to play around with it. You can build lots of stuff in this. You can, if you've seen the videos online, you can put up power lines and all kinds of stuff. But let's actually move on. So there's one thing I want to talk about. It's an optimization trick that I've learned during making this game. If you're ever using arrays for rendering, which most people should do, one thing that is really smart to do is that setting up the arrays, like you call these vertex array, and then you give it a pointer, right? And you say, here's my vertices, and then you set up, here's my UV data, and here's my blah, blah, blah. You set up all that stuff, and then you say draw, right? And it turns out that the actual drawing is not as expensive as here's my vertex. And there's a command in OpenGL called draw range, which says, I want to draw in this, but I don't want to draw the whole thing. I just want to draw this piece of it, right? So what you want to do, if you have lots of geometry, like I do, is you want to make a huge array, and then put everything in this array, right? And then just say, this is the part I want to draw. I want to draw this object, I want to draw that object, and then you do a matrix transform for each and every one of them. So you switch matrix, draw range, switch matrix, draw range, right? And the thing you want to avoid is switching your vertices, and you also hopefully want to not switch any textures or any shaders, because shader switching is, So actually, I draw the entire environment just in one single shader. All the world, all the grass, everything is in single shader. And has to have a single texture, actually. So what I do, instead of having a texture for, a grass texture, a stone texture, I have this massive texture. And then I have a little bit of grass here, and I have a little thing here, and you sort of map around in it, right? So I can draw everything with one draw call. I can draw this environment that has different pieces in it, right? Now, I can't actually have everything in one, because I don't want to draw everything. I only want to draw what's inside my view. So I compute little blocks of it that are 8 by 8 blocks, and I say, this is a piece, right? So I check, is that in my camera? Yes, it is, and then I draw. Another smart thing that I do is, I don't want to draw the grass on the other side of the globe, right? Because the grass is not going to be visible, right? So you want to have a level of detail. So what I do is that when I create my vertex array, I start by drawing all the walls, and then I draw all the ground, and then I draw all the grass, right? So that's how I put it in the vertex array. And that means that when I say the range, I can just say, draw the beginning of it. Because if it's really far away, I'm only going to see the walls. I'm not going to see the ground, because since the world is round, right, it sort of disappears underneath the horizon, right? So I only have to draw the walls. And then I get closer, okay, I got to start drawing the ground. But I don't have to draw the grass, because you're not going to see that. And as you get closer, I start drawing more and more and more of the grass. So when you're actually standing on the grass, I draw the entire thing. So it's a really smart way of sort of adding detail, right? So those edges you saw, they were sort of actually part of the grass. So I don't have to draw them far away. I can only draw them, when you get closer to things. And you can save a massive amount on that. I probably take out maybe 2/3 of my geometry just by doing that. So that's extremely nice. The bad thing about having everything in one array is that since we're moving around in the world, I can't keep everything in the world. And since people can build and change and throw, destroy stuff, I have to take these chunks out and throw in new ones, right? I have to constantly generate them. And that means that I actually have to do memory management, right? Because I have different pieces that are different sizes and they go in and out, right? So I have to defragment the memory as I'm going along. So it gets kind of messy, there's a lot of code to make it work, but damn it, you get some great performance from it. So that was my little OpenGL. If you have OpenGL questions, you should really talk to me, because I spent 4 years on phone with ATI and NVIDIA talking about stupid things you shouldn't do to OpenGL and what you should do. So let's talk a little bit about the background. One of the technologies, I have a bunch of servers here. This is the game server that actually simulates the game. This is the master server, because obviously the game is going to run on many servers. When you start the game, you're going to log in, and it's going to assign you to a server, and you're going to play, right? So the master server is going to keep track of all the players, and it's a master server, basically. And then I have this. This is the Verse server. And how many people here know about Verse? Oh, there's a couple. That's cool. So let's talk about Verse. Verse is an asset management system, and it's an API that you can talk to. And when you talk to this API, you can connect over this protocol, and you can exchange data. And whenever the data changes, you get callbacks back to it. So I'm just going to do the absolute most simple demo I can do, which is to start this application, which is my modeling tool. And I'm going to click on here. I'm going to connect to localhost. And here's one of the guns in the game. So here we go. And then I'm going to start another copy of the exact same application, right? So here another copy. These could obviously run in different countries because it's network, right? And you can now see, wow, we got the same geometry here. I'm going to do a selection here. I'm going to start moving. And you can see they're completely synchronized, right? And this is pretty nice, because it means that you can have multiple applications and they work as if they're one, right? You don't have to care about, oh, this application has to load that file from that thing, and And this system, it's a little bit hard to show, but this is actually built into the game. So if I want to tweak the graphics, I can tweak them in the modeling tool and in real time see it inside the game, right? So yeah, what you see is what you get. And that's a really, really sweet thing to have. Like, for instance, if anybody's ever done a game, you have a weapon like this, and you load it into the game, and it's 2 kilometers long. And you're like, oops. And then you scale it down, and it's only 50 meters long, and you scale it down, and then you get the right size, but it's outside of the character, and you have to go back and forth. So people build these systems where they sort of, you put a little marker where the hand's supposed to be, and then the engine has to read that and understand that and snap it and blah, blah, blah. And here I can just say, well, I can just move it until it fits, right? It's what you see is what you get. So it's really easy to sort of, you don't have that iteration, which is really, really nice. So I'm going to quickly do a little demo of this modeling tool, because it's kind of fun. This is a modeling tool that I've written. It's a subdivision surface modeling tool. And here's all the geometry that can be found in the game and a lot of other crap. Like here's a little jacket I use for cloth sim. So there's a lot of crap here. But I'm actually going to start a new geometry. So now I'm going to draw something. So to draw, you just draw straight lines like this, right? And use just your one hand, and your left mouse button you can draw. You can see when I put my mouse pointer over a vertex, it sort of gets a little symbol. That means that when I click on it, I know I'm actually going to hit it. So now I'm going to follow these blue lines, which is sort of XYZ helper lines. You can see when I get close, it sort of snaps. And then I press the right mouse button, and I'm going to snap it to this one. So now this one is right below that one. So now I built a surface. That's how simple it is. So now I'm going to keep just drawing a little bit to make something. So now you can see it's a subdivision surface, right? The cool thing about this subdivision algorithm is that if you look at the back, it's actually only subdivided in one direction, right? It didn't subdivide like this because it didn't need to. It's only curved, right? So this means I can make very sort of economical models with subdivision. So I'm going to keep drawing this thing. And if I draw like this, now it's rounded. So now you can see it takes a lot more polygons. I can actually redraw some lines here to make some sharp creases like that, right? And now if you look in the back, you can see, wow, that's sort of a perfect model for that shape, right? So this is really nice because I can actually go into the settings, if I will, and just choose the complexity, whatever I want, right? And that's kind of nice if you're making a game because you can make one model and then you can sort of export 10 different level of details. And if you want to say like, oh, level of detail number 3 should have 20% more polygons. Your artists don't have to go home and redo everything, you know. So that's pretty nice. So I'm just gonna So it has a bunch of cool features. I could talk about this tool alone for an hour, but just to show you some of the nice features. If you want to split something, you just click on an edge and split. If you want to delete something, you just cross it out. If you want to select something, you just draw a lasso around it. You get this manipulator. You can drag, move something. You can click on the middle mouse button while dragging to do an extrude. You can grab one of these arcs to rotate. You can grab outside to scale, and you can scale just one direction if you want to scale in one axis, like that. It's got a bunch of features like that. A lot of small things, like for instance, if I click the right mouse button is my view, to change the view. If I click on this thing with the right mouse button, it zooms in on the area that I've selected. So it's a lot of features like that. And just beyond that, there's all these features that are hidden, right? And they are actually in the pop-up menu. And the pop-up menu is the middle mouse button. You can click in and you get undo and redo. But if you click on something specific, like I'm going to click on this manipulator, here's all the things I can do with the selection, right? Or I can do something like, I'm going to click on this surface. Here's the things I can do with this surface. So I can, for instance, click on this one, now selected that surface, and I can click on this one with the middle mouse button and say flatten. So now we flatten the selected vertices so that they're flat with the one we clicked on to say flatten, right? And that's a really sweet function, actually, because, you know, if anybody's have ever done modeling, you know, it's really, really hard to keep your model straight. You know, they always get a little crooked. You happen to move a vertex and, it's not flat anymore. And, you know, especially if you're drawing some weird angled surfaces that, you know, cut through, you know, it's really hard because the grid wants to go in one direction, right? You want to go in X, Y, and Z. It's easy to build in those directions, hard to build in the other ones. And this one, I've noticed, I can just don't give a shit about that. I can just model as if precision didn't matter. I just don't care. And then when it looks good, I go in and say, oh, this surface should be flatten. And then it's flat. And then I don't care, right? So it's a really sweet feature. So let's show some other tools. This actually, you know, everything in the game has obviously been built with this tool. But I've actually developed some new tools that I haven't actually had the chance to use. So let's see what we can find. This is a UV mapping tool. And you can see the object here, which is the normal object you saw before the gun, right? And here's the UV mapping of it. The cool part is this. I'll go in here. I'm going to select this gun. There we go. I'm going to grab it, start changing it. Oops. I'm going to see if I can grab it better. Here we go. So you can see that it just real-time generates UV mapping. It does all the layout and everything in real time. That means, you know, I completely removed the entire stage of UV mapping. And anybody who's ever UV mapped knows that it's about the most boring task in the universe. So my goal is really, by writing a tool like this, which took me about 2 weeks, I've spent a lot of time, but hey, I've never ever have to do UV mapping again. So eventually, of course, I'm going to save a lot of time. Oh, there's some features here. Yes, animated, if you want to see how it works. Thank you. You gotta have fun too. Okay. So moving on, I'm going to show you the next tool. I think I might want to run this from my compiler. It just is cooler that way. Oh, I gotta show you this. This is just this is not a part of the game. It's something I use for development. So it's just a little behind the scenes look at what's going on. Wakey, wakey. It's coming. Apparently. Oh, sorry. Need to turn the server off. There we go. Fun demo. There we go. So this is actually a top view of the world. And now we can actually see what the world looks like from sort of the outside. And you can see I have little names on what things are. And now I have a bunch of characters actually here. You can see they're moving around. I'm simulating this at a very, very high speed. And they are actually on the way over to this little settlement here. And they're about to fight them, because that's what I'm working on right now. So here you can see there's a lot of fighting going on, a lot of shooting, and yeah. So this is really, if you're building a game where you see everything from first-person point of view, you can't really know what the hell is going on the other side of the world. It becomes really hard to debug, right? Imagine you have to walk 2 kilometers every time you want to see what the hell is going on. Not really fun when you're doing, development. So this tool sort of helps me to see the world from the outside. And this is actually the server, but in a sort of different version that has the graphics. And it's getting real slow now because I'm doing too much stuff. Actually, I can run this at different speeds. So I can run it 10,000 times faster than real time. The reason why I do that is I want to do things like erosion, right? How the world is slowly changing from erosion. And debugging erosion in real time, no, you don't want to do that. I can tell you this has actually been a bit of a nightmare project lately, because the little characters running around actually do things. Like they go out and set up, power grids and things like that. And then the AI has to first figure out that you can build a power grid, and then figure out where it's going to go, and then send out little characters to actually build it, right? But what happens if, as soon as you've figured out where to build the grid, somebody builds a wall that will stop the grid, right? Then you have to rethink the grid, right? And what if one character gets stuck or killed on the way to his assignment, right? That's possible. You should be able to stop someone from building something, except if that happens, the AI must have some sort of counter against that. They must send a new guy, right? Or they must do something else, right? And that turns out to be incredibly complex, because the system is meant to be able to fail. And that means it's really hard to debug. Because as soon as you see something that doesn't look right, you don't know if that's actually the way it's supposed to fail, or if it's actually failing, right? And you start going by statistics rather than success and failure, right? You say, okay, I want these guys to have a pretty good chance of building this grid, but they shouldn't always succeed, So can I make it so that they don't actually succeed all the time? And at the same time, can I make it so that they're not completely moronic and never can get anything done? And that's really, really hard, actually. I'm starting to understand why people haven't built this game like this before. Okay, so this I'm going to show for 1 second, and then I'm going to quit it. So this is a modeling tool. This is a scene graph tool. You can see all the things that we have in the world and blah, blah, blah. I know, we can actually look at this object. Ooh, what's that? Yeah, it's the gun. And actually you can bring up different types of objects and play with them, and you can, for instance, clone them if you need another one, and manage. Oh, and you can do this. If you see there's little spaceships flying around, come on, show me one. It's way too much glare. There we go. If you click on one of those, you can waste time. Not all features are to save time. Some are to have fun. A friend of mine has an original asteroid, so I was able to sort of have a good look at the real one. Anyhow, so this is a scene management tool. You can click on an object, see what's inside of it, blah, blah, blah. Data, interesting, I guess. But I'm going to quit that. And the reason I'm going to quit that is that I'm going to quit the server that I was running, and I'm going to start another one, a better one. Here's a verse server. And this server has some fun content. Because basically, the asset management system that around Verse can do so much more than my game can. So it's more fun to show some other data that uses more of Verse. And that's where we are now. And go. Gadget, go. Here we go. So this is a little scene. It was obviously made in the modeling app, so yeah. And now you can, for instance, click on something like this. This is an object, and it actually has a bit of geometry. It's got a bit of material, and it's got a bit of texture. Cool. So now we can actually look at this and sort of understand where the data is. We can do some really cool things, like we can, I'm going to add a tag and say, this is, oh, sorry, I'm not going to do that. Let's see if I have a cool app I can show. No, I don't, of course. No, I don't. Let's skip that demo then. That's not too fun. So what you actually can do, just to sort of show it, is that you can tag objects, because Verse has a tagging system. So you can, for instance, tag objects with what health they have, AI, and things like that. And that means that you can communicate with your tools and your game, which is really sweet. And one of the things I built is a system that sort of goes both ways. So in my code, I can write a code line that says, I have an object, right? And I want to say, give me the health of this object. And the name of the thing is health. It's a floating point value, and the default value is 100. And then the function will return a value. Now, normally that will be 100 because there will be no content on the server, right? But if I'm a programmer, I need that content, right? And if somebody hasn't provided the content, I'll get 100, which means that I can keep working. I don't have to wait for someone else to produce data, which is really sweet for me as a programmer, right? But then the cool thing is that that piece of data is actually transferred onto the server, so the object actually gets a tag that says health 100. And that means that when the artist or designer comes in, they can say, oh, there's a value here. I can change it. Cool, right? And they can play with it, right? And that means that the programmer never have to tell the artist, this is how you do health, right? Oh, no, you shouldn't write life. It should be health, right? Those kind of discussions never have to occur because you just say, well, I'm going to take this data, and then all of a sudden it's going to appear in the interface of the artist. It's going to be like, ooh, there's a new value I can play with, right? And actually, my intention is to do the same thing with geometry as well. So let's say you're doing a tank in an action game, right? And what you would do then is that you would say, OK, I want to do a tank. It's called tank. It's a box. It's green. It's about this size, right? And that means that all that data would be created on the server, and then the artist wouldn't accidentally make a tank that is 5 times larger, or that has the wrong naming or something like that. They get sort of something really rough, right? It also means that if the stupid artist accidentally deletes the files, the game will still run, right? It'll look like crap. It'll look like a bunch of boxes. But there's no, if you have a huge team of 100 people, the chance that somebody's going to do something stupid is pretty high. And if that breaks your game, you're going to be doing nothing except, screaming, who did the blah, 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 and, office politics follows. So back to this. I'm now going to hide this thing, and I'm going to turn on shaded. Whoops. Turn on wireframe. Here we go. So this is an OpenGL2 rendering engine that draws this world. It's a little buggy because this is an NVIDIA chip, and they don't do nice things. But you can, for instance, move your light source around. It's all real time. You can play with all kinds of. You can see these materials here. They look weird. This material, I can show you, that's actually this material. And it actually has a little tree inside of it, which is Verse way of describing materials. And here we can see it's outputting an added of a direct and ambient light, just normal lighting, and then it has a reflection on that, but the reflection is multiplied by this ramp, and this ramp is in turn mapped on the view angle. So you get sort of brightness in the edges and blackness in the middle. So you get that sort of car paint, sheen that, if you look straight on a car paint, it looks red, if it's a red car. But if you look at the edge, you get this glare and nice, effect. So that's kind of what you do here as well. I'm getting way too much shadows here. Let's turn off the shadows. They're too dumb in this hardware anyway. So here's another one, which is kind of a lot of drunken programming. This is actually a refracting with sort of a color aberration material. This one is really funny. It's actually really simple. It's just a reflection, but it also has a little bit of displacement mapping, so you can play with the displacement of it if you want to. It's all real time. So these are pretty fun tools. So I think I'm getting towards the end. I have so much stuff to show that it gets very, very, very condensed. But if I don't know how many of you do games or are interested in games, but I guess it applies to any demo scene related stuff as well. And that is, tools is really where you should be working. If you have better tools, you will win, because the guy with the best tools can do more, right? A tool is an investment that you'll get back, right? Every time you do something, it's a little bit easier than for the other guy who doesn't have the tool, right? And right now, we're at this point in computer graphics where absolutely nothing is happening, because Autodesk owns everything. They have stopped developing everything. There is no 3D program today that is younger than 10 years, basically. And Photoshop is 25 years old. You think anybody can do something new? Kind of time to do that, right? So what I'm trying to do is say, even if I have a lot of work just doing the game, just by making better tools, I can actually save so much time that I can actually do things I couldn't do before. And the cool thing is that once I've done the tools, I can use the tools over and over again, right? My next game, I'm going to use the same tools, except I'm going to do even more tools. So I'm going to be even better, right? And as I keep working, I'm going to get better and better, and I'm going to be able to do more and more stuff. So that's why I think that as a programmer, we are sort of made to look at and find patterns and things. And artists don't get that, because artists, they slave. So as a programmer, you can take away so much work from them so easy if you start thinking about the problems and not just saying, well, Maya can do it, right? Because Maya really can do it. And that's also a historical thing that, back when first time I saw Maya was in 1994. And back then, we couldn't believe that the graphics in the display were filled, that they weren't wireframe. That was like, oh my God, And back then, the thing was you can't do anything because we have so many limitations. So the whole companies were built around the idea of what can we do, right? And now we can do fire, water, or anything, right? But the thing is, what nobody's thinking about is how much can we actually get done, right? How efficient are we? So that's really what I think about computer graphics in general, and games in particular, is that the great new battle is who can be the most efficient. When you build an engine today, you should not think, how can I draw the most polygons? You got a great polygon pushing graphics card that can do anything. That's not the problem. The problem is creating all those polygons to draw.
Great.
So,
Thank you for the fascinating show. I think we are running out of time. Maybe
yes.
One more thing.
No, I'm actually done. If anybody wants to come up and talk to me and get a card. Oh, one more thing. All the tools you've seen today, except for the UV tool, is downloadable on my website, including source code. They build on Windows, Mac, and Linux. So go have fun, is really what I want to say.
Thank you.